नमस्ते बच्चों, हमेशा खुश रहो। Myself, Dr. Monica Trivedi. Today's topic is oxidation of hydrocarbons. Okay, so the oxidation of hydrocarbons on oxidation of alkane. First process for this is epoxidation. Okay, like in olefin, the double bond react with per acid to give epoxide. The most useful reagent for the effective alkane oxidation is metachloroperbenzoic acid. It is also known as MCPBA. Okay, this MCPBA is an electrophilic agent, and according to it is react with the nucleophilic alkene. Okay, so you can see in this reaction the nucleophilic alkene having the two double bond combined with the epoxide. Okay, so this OO bond is present in a reactant is known as a epoxidation bond. So you can see in this mechanism the double bond between carbon react with the oxygen, and this oxygen hydrogen bond will give the electron to the carbon. So you will get the transition state between the oxygen carbon and oxygen with another oxygen and hydrogen of epoxide. Okay, so now in a perbenzoic acid. Okay, now you will get what will happen. This hydrogen bond, the hydrogen oxygen and oxygen bond will break, and new bond oxygen carbon and oxygen carbon will meet. You can see the ring here over here combined with the carbon. Okay, so this is the epoxidation process for the oxidation of alkane. Okay, you can see another example. So this kind of reaction is a syn addition, okay, to the double bond. Okay, as the cis alkane give only the cis product, and the trans alkane is only give the trans product. Okay, so this is called a syn addition. Okay? So if you can see here the trans alkene, the product will be trans. If you see the cis alkene here, you will get the cis product here. Okay, so the alkyl substitution alkenes react faster than the less alkyl substituted alkane. Thus, it is possible to oxidize more suitable alkane in the presence of less suitable ones. So, we can see here the double bond. We have two double bonds here. Okay, so what kind of double bond will use to react with the alkene for the per acid. Okay, so here the less alkyl substituted alkene will undergo in the oxidizing process. You can see in the ring the double bond is present, as well as outer the double bond present. So the outer of the double bond is going to react with the MCPBA. Okay, and it will give the epoxide. The next one is, you can see there is a cyclic alkane. The reagent approaches from the least hindrance side of the double bond. Okay, so this is the double bond, so it will give the product like this. Okay, now you can see another example. It is has also double bond CC. So the product will it is a conjugated diene with the double bond, and another is unsaturated group product with the rate of oxidation because of the delocalization of pi and alpha beta unsaturated acid or ester. Okay, due to this reason, the required strong agent like CF3COOH or MCPBA. Okay, so in presence of CFCCOOH or MCPBA at certain temperature, it will give the epoxide. Okay, now you can see the mechanism of Baeyer-Williger oxidation process. Okay, so here you can see the epoxidation of alpha beta unsaturated aldehyde and ketone is the best performance by the action of the nucleophilic reagents such as H2O2 or the tributyl hydroperoxide in alkaline solution. Okay, the per acid cannot be used in this compound because of they give the Baeyer-Williger oxidation. Okay, so in this reactant, the double bond is present here in presence of H2O2. Okay, in presence of H2O2, it will give the epoxide. Okay, you can see another example. Oxidation with per acid is not only the way to convert the alkane into a epoxide. It is the process which found to the alkyne with tributyl hydroperoxide in the presence of vanadium. Okay, and molybdenum reactant like a catalyst. Okay, so it will provide it will give the preparation method for the epoxidation. Okay, so molybdenum catalysts are most effective for the epoxidation of the isolated double bond and vanadium catalyst for the alkylic alcohols. Okay, so here you can see the example for vanadium catalyst. Okay, this is the another reaction for the oxidation of epoxide is sharpless method. Okay, what is the sharpless method? In a sharpless method, the epoxidation of the alkylic alcohols and can also be achieved by the sharpless method. This is the one of the most valuable tool to chiral synthesis. The sharpless asynthesis oxidation is the method for the converting allylic alcohol to the chiral epoxy alcohol with a very high enantiomer selectivity. Okay, like the tetrabutyl hydroperoxide and the titanium tetraisoperoxide were used in this kind of mechanism, and for it DET like diethyl tetrate is the best chiral ligand for this kind of reaction. You can see for the plus DET it will give the S product, and for the minus DET will give the R methyl glycine. Okay, the last one is perhydroxylation. The perhydroxylation of the carbon-carbon double bond is usually in organic synthesis and can be effective with a number of different reagents. Okay, so this is the simple process for the oxidation of alkenes. Okay, another is potassium permanganate. You can you know that the potassium permanganate is a very good oxidizing agent. So here you can see the reaction with the double bond of carbon and MnO4. There is a mechanism for it, and you can see the MnO4 react with this alkane, and it will give the intermediate, and now this intermediate by losing by reacting the hydrolysis, it will give the product intermediate, and finally we will get the dialcohol. Okay, diol. Okay, you can see that this is the final product is a diol, and this kind of reaction is a syn addition with a 2-hydroxyl group. Okay, you can see another example of the camino for reduction. A double bond of carbon will reduct and give the product like diol OH. Okay, so in a cyclic compound you can also see the double bond will reduct and give the glycol. Okay, so the next one is oxygen tetraoxide, which is also a good oxidizing agent. The addition of an alkyl osmium tetraoxide in ether. Okay, so in this process you can see the double bond of the alkene will combine with the osmium oxide, and it is also known as a 3+2 oxidation process. It will give the intermediate. Okay, you can see the alkene combined with the oxygen, and also the osmium breaking of the bond of with the osmium oxygen. Okay, now the osmium and oxygen bond will completely decompose it, and finally we get the diol. Okay, and the second mechanism is 2+2 cycloaddition. Okay, it will also give the product of syn addition. Okay, so this is another example of osmium oxide for the reduction of double bond alkene. Okay, you can see the syn addition over here. You can see the syn addition in this compound as well. Okay, so the oxidation of alkyl alcohol with the osmium tetraoxide provide a route like 1 through 3 triol, and the structure will be found as a natural product. Okay, in a sharpless method, it is recently used to lead to control the enantiomer selective of the hydroxyl reaction. Okay, so you can see the reaction of the osmium oxide. In presence of osmium oxide, the addition of diol. You can see the other example of osmium oxide is the product will be the diol. Okay, so these are the simple example of oxidation process in alkenes. Thank you very much.